Determining the maximum size sub-panel for residential installation involves several crucial guidelines. Firstly, you must determine the total available amperage at the residential service panel. This is typically found to be 100 amps, 150 amps, or 200 amps. Secondly, the maximum amperage of the sub-panel should not exceed 80% of the available amperage at the service panel. For example, if the service panel is 100 amps, the maximum sub-panel amperage should be 80% multiplied by 100, which equals 80 amps. Thirdly, the feeder wire connecting the sub-panel to the service panel must be appropriately sized to carry the sub-panel's amperage. The length of the feeder wire also affects its current carrying capacity. Longer wire lengths require thicker wire. Fourthly, the circuit breakers or fuses in the sub-panel should be rated for the appropriate amperage to protect the circuits and appliances connected to it. Fifthly, compliance with the National Electrical Code, or NEC, is mandatory. NEC Article 408.16 requires the sub-panel to be rated for not less than 80% of the available amperage at the service panel. NEC Article 408.18 limits the feeder wire length to 100 feet. Sixthly, local electrical codes may impose additional requirements or restrictions on the maximum sub-panel size. Additional considerations include ensuring that the size of the sub-panel should be sufficient to meet the anticipated electrical needs of the area it serves. It is recommended to have a licensed electrician assess the electrical system and determine the appropriate sub-panel size. Oversizing the sub-panel can lead to safety concerns and may not be code compliant. The available amperage dictates the sub-panel's maximum size. Calculate 80% of your main panel's amperage rating. Size the feeder wire according to the sub-panel's amperage and length of the run. Use appropriately rated circuit breakers or fuses in the sub-panel. Adhere to NEC Article 408.16 and 408.18 for sub-panel rating and feeder length. Check local electrical codes for further restrictions. Ensure the sub-panel meets the area's electrical needs. Consult a licensed electrician for assessment and proper sizing. Oversizing can compromise safety and code compliance. Let's delve deeper into each of these points. Available amperage at the main service panel is the foundation. Common residential service panel ratings are 100 amps, 150 amps, or 200 amps. The rating is usually clearly marked on the main breaker. Determining the available amperage is the starting point for calculating the maximum allowable sub-panel size. The 80% rule is a critical safety margin. Limiting the sub-panel's amperage to 80% of the main panel's capacity prevents overloading the system. This provides a buffer for unexpected surges and ensures the main breaker isn't constantly tripping. For example, with a 150 amp main panel, the maximum sub-panel amperage would be 120 amps, calculated as 80% of 150 amps. Feeder wire size is crucial for safe and efficient power delivery. The feeder wire carries electricity from the main panel to the sub-panel. Undersized wires can overheat, leading to insulation damage and potential fire hazards. The National Electrical Code, specifically Table 310.16, dictates the appropriate wire gauge based on amperage and wire type. Longer wire runs require thicker wire due to voltage drop. Voltage drop occurs when the voltage at the sub-panel is lower than at the main panel due to the resistance of the wire. The NEC recommends limiting voltage drop to 3% for feeders. To compensate for voltage drop, increase the wire gauge. Online voltage drop calculators can help determine the appropriate wire size for specific lengths and amperage. Circuit breaker and fuse ratings are essential for overcurrent protection. Circuit breakers and fuses are designed to protect circuits from overloads and short circuits. They interrupt the flow of electricity when the current exceeds the rated amperage. The circuit breakers or fuses in the sub-panel must be sized appropriately for the circuits they protect. For example, a 15 amp circuit should have a 15 amp circuit breaker. The total amperage of all the circuit breakers in the sub-panel can exceed the sub-panel's main breaker rating. This is because not all circuits will be loaded to their maximum capacity simultaneously. NEC requirements provide a baseline for safe electrical installations. Article 408.16 mandates that the sub-panel be rated for at least 80% of the main panel's available amperage. Article 408.18 limits the feeder wire length to 100 feet to minimize voltage drop. Other relevant NEC articles cover grounding, bonding, and overcurrent protection. Familiarizing oneself with the NEC is crucial for safe and code-compliant electrical work. Local electrical codes can be more stringent than the NEC. Local jurisdictions may have additional requirements or restrictions on sub-panel installations. These codes often reflect local environmental conditions or specific safety concerns. Check with the local building department or electrical inspector to determine the applicable local codes. Additional considerations encompass the anticipated electrical load. The size of the sub-panel should be adequate to handle the electrical demands of the area it serves. Consider the number of circuits needed for lighting, receptacles, and appliances. Calculate the total anticipated load in amps. Choose a sub-panel with sufficient capacity to accommodate the load with some room for future expansion. Consulting a licensed electrician is highly recommended. A licensed electrician has the knowledge and experience to assess the electrical system and determine the appropriate sub-panel size. They can perform load calculations, select the correct wire size, and ensure compliance with all applicable codes. Engaging a professional ensures a safe and reliable electrical installation. Oversizing the sub-panel can be counterproductive and potentially dangerous. While it may seem like a good idea to install a larger sub-panel than needed, it can lead to safety concerns. Oversized panels can encourage overloading circuits, increasing the risk of fire. Furthermore, an oversized sub-panel may not be code compliant. Always choose a sub-panel size that is appropriate for the anticipated load and in accordance with electrical codes. In summary, determining the maximum sub-panel size involves considering available amperage, feeder wire size, circuit breaker ratings, NEC requirements, local electrical codes, and anticipated electrical load. Consulting a licensed electrician is essential for a safe and code-compliant installation. Now let's elaborate on the practical aspects of each guideline. When assessing available amperage, look at the main breaker in your primary service panel. Its amperage rating is usually printed clearly on the breaker handle. This number represents the total amount of current your service panel can safely handle. If your main breaker is rated for 200 amps, that's your starting point for calculating the maximum sub-panel size. Remember, you're working with electricity, and safety should always be the top priority. To reiterate, when calculating the sub-panel amperage, apply the 80% rule. This means multiplying the main panel's amperage by 0.80. So, if your main panel is 100 amps, the maximum amperage for your sub-panel is 80 amps. This 80% rule is a safety factor built into the electrical code to prevent overloading and overheating. Moving on to feeder wire sizing, this is where things can get a little more technical. The feeder wire is the cable that runs from your main service panel to your sub-panel. It needs to be thick enough to safely carry the amount of current that your sub-panel will draw. The size of the wire, or its gauge, is determined by its ampacity, which is the amount of current it can safely carry. The longer the wire run, the larger the wire you'll need to compensate for voltage drop. Voltage drop is the decrease in voltage that occurs as electricity travels along a wire. Excessive voltage drop can cause appliances to malfunction and can even damage electrical equipment. NEC Table 310.16 is your friend here. This table lists the ampacity of various wire sizes based on the type of insulation and the temperature rating of the wire. You'll need to consult this table to determine the correct wire size for your sub-panel. Also, consider using a voltage drop calculator to ensure that your wire size is adequate for the length of the run. These calculators are readily available online and can save you a lot of headaches. Choosing the right circuit breakers or fuses is another critical step. Circuit breakers and fuses are designed to protect your electrical circuits from overloads and short circuits. When the current in a circuit exceeds the ratio of the breaker or fuse, it trips or blows, cutting off the power to the circuit. This prevents overheating and potential fires. The circuit breakers or fuses in your sub-panel should be sized appropriately for the circuits they protect. For example, a 15 amp circuit should have a 15 amp breaker or fuse. It's important to note that the total amperage of all the breakers in your sub-panel can exceed the amperage rating of the sub-panel itself. This is because it's unlikely that all of the circuits will be drawing their maximum current at the same time. However, the main breaker in the sub-panel will trip if the total current draw exceeds its rating. The National Electrical Code, or NEC, is the Bible of electrical safety. It contains a comprehensive set of rules and regulations for electrical installations. Complying with the NEC is essential for ensuring the safety of your electrical system. NEC Article 408.16 specifies the requirements for the rating of the sub-panel. As mentioned earlier, it must be rated for at least 80% of the available amperage at the service panel. NEC Article 408.18 limits the feeder wire length to 100 feet to minimize voltage drop. In addition to these specific articles, there are many other NEC articles that are relevant to sub-panel installations. These articles cover topics such as grounding, bonding, and overcurrent protection. It's a good idea to familiarize yourself with the NEC before undertaking any electrical work. Don't forget about local electrical codes. Many local jurisdictions have their own electrical codes that are based on the NEC but may include additional requirements or restrictions. These codes often reflect local environmental conditions or specific safety concerns. It's important to check with your local building department or electrical inspector to determine the applicable local codes before starting any electrical work. In addition to these technical considerations, it's also important to consider the anticipated electrical load when determining the size of your sub-panel. Think about all of the appliances, lights, and other electrical devices that will be powered by the sub-panel. Calculate the total anticipated load in amps. Then choose a sub-panel with sufficient capacity to accommodate the load with some room for future expansion. It's always better to oversize the sub-panel slightly than to undersize it. Finally, and perhaps most importantly, it's highly recommended to consult a licensed electrician before undertaking any electrical work. Electrical work can be dangerous if not done properly. A licensed electrician has the knowledge, skills, and experience to safely and correctly install a sub-panel. They can also help you determine the appropriate size sub-panel for your needs and ensure that your installation complies with all applicable codes. Remember, electricity is not something to be taken lightly. If you're not comfortable working with electricity, it's best to leave it to the professionals. Oversizing a sub-panel might seem like a good idea for future needs, but it can lead to safety issues if not done correctly. An oversized panel can create a false sense of security, leading to overloading individual circuits. This can cause the circuit breakers to trip frequently, or worse, it can lead to overheating and potentially a fire. It's also important to consider the cost of an oversized sub-panel. Larger panels are more expensive than smaller ones. Unless you have a specific and well-defined need for a larger panel, it's generally best to stick with the size that's appropriate for your current and near-term needs. Load calculations are a critical step in determining the appropriate size sub-panel. A load calculation is a process of estimating the total amount of electrical power that will be used by all of the devices connected to the sub-panel. This calculation takes into account the wattage of each device, as well as the amount of time it will be used. There are several different methods for performing load calculations, but the most common is the standard method outlined in the National Electrical Code. This method involves adding up the wattage of all of the devices connected to the sub-panel and then applying a series of demand factors to account for the fact that not all of the devices will be used at the same time. Demand factors vary depending on the type of device and the number of devices connected to the circuit. For example, lighting circuits typically have a demand factor of 100%, while receptacle circuits may have a demand factor of 50% or less. Once you have calculated the total load, you can use this information to determine the appropriate size sub-panel. The sub-panel should be sized to handle the total load with some room for future expansion. Grounding and bonding are essential safety measures for any electrical system. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. Bonding connects all of the metal parts of the electrical system together, which helps to equalize the voltage and prevent shock hazards. The National Electrical Code has specific requirements for grounding and bonding. These requirements vary depending on the type of electrical system and the location of the equipment. It's important to follow these requirements carefully to ensure the safety of your electrical system. Wiring methods refer to the types of cables and conduits that are used to run electrical wiring. There are many different types of wiring methods, each with its own advantages and disadvantages. Some common wiring methods include non-metallic sheath cable, commonly known as Romex, metallic conduit, and electrical metallic tubing. The choice of wiring method depends on the application and the local electrical code. Non-metallic sheath cable is commonly used for residential wiring, while metallic conduit and electrical metallic tubing are often used for commercial and industrial wiring. Regardless of the wiring method used, it's important to install the wiring properly and in accordance with the National Electrical Code. This includes using the correct size wire, supporting the wire properly, and protecting the wire from damage. Electrical permits are required for many types of electrical work, including sub-panel installations. The purpose of an electrical permit is to ensure that the work is done safely and in accordance with the local electrical code. The permit process typically involves submitting plans to the local building department and having the work inspected by an electrical inspector. Electrical inspections are conducted to verify that the work has been done in accordance with the local electrical code. The inspector will check the wiring, grounding, bonding, and other aspects of the electrical system to ensure that they meet the code requirements. If the work passes inspection, the inspector will issue a certificate of occupancy. This certificate is required before the building can be occupied. In conclusion, determining the maximum size sub-panel for residential installation is a multifaceted process that requires careful consideration of several factors. These factors include available amperage, feeder wire size, circuit breaker ratings, NEC requirements, local electrical codes, anticipated electrical load, grounding and bonding, wiring methods, electrical permits, and electrical inspections. By following these guidelines and consulting with a licensed electrician, you can ensure a safe and code-compliant sub-panel installation.